This video is going to cover the quarter 3 review assignment. Feel free to jump around and watch any of the sections of the videos that you have questions on, and you can skip anything else. So let's get started. Question number 1, what is 28 over 5 as a decimal? Fraction bars are the same, can be thought of the same as division. So I'm going to go to my Desmos calculator, and you have access to that on your assignment, and type in 28 divided by 5, and that gives me a grand total of 5.6. All right, moving on. What is 0.17? That bar over that means it's repeating as a fraction. Now, the way I write any fraction is going to be the same. I'm going to write the number that comes after the decimal on top of my fraction, so 17. Now, on the bottom, it differs. If there's a repeating bar, I am going to count the number of digits. 1 and 7, it makes 2 digits. I'm going to put that same number of 9s in the denominator. So 17 over 99. If it didn't have that repeating bar, I would put 17 over 100. But 17 over 99 cannot be simplified, so that is my final answer. Now let's look at 0.68. As a fraction, 68 on top, and on bottom, 2 digits. There's 2 digits. So I'm going to put it over 100. So 2 zeros for the 2 digits that I have. Just as a quick reminder, if I had 0.125, I would put 125 over 1,000. If I had 0.125 repeating, then I would put 125 over 999. So that is the difference. The denominators are the difference between repeating and non-repeating. Now make sure that your answer is simplified. 68 over 100. Well, I can do that by hand, or I can let my calculator do that for me. Clear all. 68 over, whoops, I didn't get that right number in there. 68 over 100. Click the fraction button over here on the side, and I get 17 out of 25. Rational or irrational? Remember, in order to be considered rational, you have to be able to write the number as a fraction. Okay, things that I can write as a fraction. I can write whole numbers as fractions. I can write decimals as fractions, like that last example. I can write 0.17 repeating as a fraction. But things that I can't write as fractions are things like pi, because it goes 3.1415, and it continues on with no pattern. Or some square roots, so square root of 13 is also irrational because it just continues on forever. So let's look at our options. 1/9, can it be written as a fraction? It already is rational. Square root of 4, well, simplify it first. Square root of 4 is 2. Can 2 be written as a fraction? You bet. 2 over 1, rational. 2 pi. Well, if I multiply 2 by 3.1415 and it continues on, it is not going to remain rational. It's going to continue on forever without repeating. So irrational. Square root of 72. Well, I'm not sure what that is in my head, so I'm going to go to my calculator and test it out. Square root of 72. And I can see that it's 8.485. Now there's no repeating digits. It continues on with no pattern. So I would label this as irrational. I can't write that as a fraction because it doesn't repeat or stop. 6.8, can I write that as a fraction? You bet. 6 as a whole number, and 8, there's only one digit after the decimal place, so 8 over 10. And that is a fraction, so rational. All right, question number 5. Explain why the square root of 60 is an irrational number. That's similar to why the square root of 72 on the previous question was irrational. When I type that into my calculator, square root of 60, 7.745, hey, my answer doesn't repeat or terminate. so we can't write it as a fraction. There's no way for me to convert it. That is question number 5. Question number 6, find the square root of 49. And here's where my calculator comes in super handy. Square root of 49. Whoops, typed in the wrong number. 49. 7 over here on the right hand side. Done. Square root of negative 100. So my answer is going to be negative, and then square root of 100 I'm going to find is 10 if I type that into my calculator. Evaluating an expression. Now, if I'm evaluating this expression, I'm going to, remember, follow order of operations. It's PEMDAS, but I'm going to deal with exponents and radicals at the same time. So I'm going to first, there's no parentheses, so I'm going to first simplify the square root of 16. Square root of 16 is 4. So 3, that's multiplication, times 4 minus 5, and simplify that. 3 times 4 is 12, minus 5 is 7. Evaluating this expression. So PEMDAS, exponents and radicals happen at the same time. So I'm going to work inside my parentheses first. And I'm going to, well, inside the parentheses, there's addition and a radical. So I'm going to simplify my radical. 3 times the square root of 64 is 8. I bring everything else down. Still working inside my parentheses. So 3 times 10. And finally, 3 times 10 is 30. Estimate the square root to the nearest integer and tenth. So I'm going to come to my calculator. Square root of 29. So square root of 29. Now I'm going to write down a couple of those digits. So 5.3851. 5.3851. So remember that an integer is just another name for a negative or positive whole number. So if I'm rounding to the nearest integer, I'm going to draw my line after my decimal. I'm not going to include any decimals, but I do need to look at the number after the decimal to say, hey, is that 3 big enough to make that 5 closer to a 6? Now, 3 is not even halfway to 6, so I am going to stay the same. So if I round to the nearest integer, I've got a 5. Now, rounding to the nearest tenth, I am going to change where I draw my line, changing colors. Tenth is 1 decimal place. So I have 5.3. I'm going to look after the 3. And I'm going to ask myself, is that 8 making that 3 closer to a 4, or should it stay the same? Well, that is over halfway. So I'm going to change my 5.3 to a 5.4. It's closer to 5.4 than it is to 5.3. And that would be my final answer. Make sure you include the whole number in your answer. Question 11, simplify this radical. Now, you'll notice on your assignment that it is multiple choice, and you'll notice that decimals are not a possibility. So I'm not going to type this into my calculator. What I'm going to do is I'm going to see if I have any perfect squares inside my square root. Well, how do I do this? I'm going to create a factor tree. 45 splits into two factors are 9 times 5 is 45. I'm going to circle any prime numbers that I have, and any non-prime numbers that I have, I'm going to continue to split. So 9 can be split into 3 times 3. Now, 3 is a prime number and 3 is a prime number. Those can't be split anymore, so I'm done making my factor tree. And what I'm going to do is I'm going to rewrite that. 3 times 3 times 5. Well, remember, square roots are just, if I take the square root of a number, I'm looking for a number that's being multiplied by itself in order to simplify. Well, there's 3 being multiplied by itself. I'm going to pull out the 3 of my radical. Only 1 3 for the pair. Now it's gone. And I'm going to write my radical sign. Now, is there a pair, another 5, underneath that radical symbol? There is not. So it has to remain. And this would be my final answer. 3 radicals of 5. Let's look at a different example. Simplify this expression. Adding radicals is the same as combining like terms. So for example, if I had 2x plus 11x, that would simplify to 13x. Well, this radical 3 acts like a variable. Because they're the same, I can add the numbers in front. 2 plus 11 was 13. And just like on this example over here, with my x's, I just brought along the x for the ride. So I'm just going to bring along my square root of, or radical of 3 for the ride. And that would be my final answer. Now, if I jump to this problem, I see I have another addition problem. But I want you to notice that these radicals are not like terms. So I cannot just add them together, and I can't add what's on the insides. Notice I didn't even add what was on the insides on this previous problem. So in order to simplify this, I need to ask myself, can I simplify radical of 18 or 2's roots of 2 to anything simpler that may combine? Well, I'm going to make a factor tree of both of my radicals, 2 and 1, and those are both prime, but neither of them repeat. So there's nothing that I can pull out of my radical. So I'm going to just rewrite it. Plus, let's simplify 18. 18 can be simplified to 2 and 9. 2 is prime, but 9's not, so continue split. 3 and 3 are both prime. Well, there's a pair of 3's, so that gets to be pulled out front. So inside of my in front of my radical, and 2 remains on the inside. Well, all of a sudden, if you'll notice, my radicals are the same. So now I have like term radicals, so I can combine them. Remember, I only add the numbers in front. So 2 plus 3 is 5 radicals of 2. And that's my final answer for that. Number 14, multiplication. I love multiplication because I do not have to follow the like term rule. I can just multiply what's outside of my radicals and what is inside my radicals. 4 times 10 is 40, and 2 times 3 is 6. And because the 2 times 3 is inside my radical, 6 is going to remain inside my radical. One thing I have to do is check and make sure that I cannot simplify it. There are no pairs. 2 and 3 are not like, and I'm going to leave it my answer, 40 roots of 6. Now that we've talked about simplifying expressions, let's talk about the Pythagorean theorem. So question number 16 has a right triangle. As soon as I see a right triangle, I'm going to start thinking a squared plus b squared equals c squared. Let's go ahead and simplify, solve our problem. So it says find the missing side length. I am looking for x. Before I do anything, I need to make sure I know which side is A, which side is B, and which side is C. A is always going to be either my shortest side. A and B are always going to be my 2 shortest sides. Now, it doesn't matter which one is which, but it does matter that C is my longest side. So X is C. This is my longest side, and another reason I know it's my longest side is because it is diagonal from this right angle. It is not touching that right angle. So C is my X value. I usually label my shortest side as A and my middle size as B, just for fun. So A squared is now 5 squared, B squared is now 24 squared, and C squared is now X squared. I am not going to add anything together until I have done exponents because of order of operations. So 5 times 5 is 25. 24 times 24, my goodness, 24 squared, I don't know what it is. So 24, clear my calculator, 24 squared is 576 equals x squared. So I'm going to add these values together. 2 25 plus 5, 25 plus that is 601 equals x squared. Now, how do I get rid of that x, the squared on that x? I'm going to undo it by taking the square root. And I'm going to use my calculator for that. So square root of 601 is 24.515. And it asked me to round to the nearest tenth. So 24.515 nearest tenth. I'm going to draw my line. I'm going to look after the line, and I'm going to ask myself, does that make my 5 round up? That's not even halfway. So I'm going to leave it as 24.5. All right. Find the missing side length of this triangle. Again, a right triangle, so a squared plus b squared equals c squared. Again, I'm going to label my sides. The side across from my right angle is C. That is the most important one that we get correct. The other two can be whichever way. I think this looks shorter, so I'm going to label it A and B. So this time, x squared plus 16 squared equals 20 squared. Using my calculator, I don't know what x squared is, so I rewrite it. 16 squared is 256. And 20 squared, I happen to know offhand, is 400. Now, x is over here this time, and before you just take a square root, remember that x is not by itself. I have to get rid of the plus 256 first. Because it's addition, I'm going to use the opposite operation, and I'm going to use subtraction. So 400 minus 256 is 144. And I'm going to take the square root of 144, and I'm going to get a whole number this time. 12 times 12 is 144, so x is equal to 12. Continuing, select whether the following right triangle is or is not a right triangle. Well, if it is a right triangle, then my a squared plus b squared is going to equal c squared. I am looking to make sure that these two values added together equal c squared. If it doesn't, it's not a right triangle. So again, I'm going to go to my triangle. I'm going to list my smallest side as A, my middle size as B, and my largest side as C. 6 squared plus 8 squared equals 10 squared. I'm going to test it out. 6 times 6 is 36. 8 times 8 is 64. 10 times 10 is 100. What is 36 plus 64? It is also 100. Because these are equal, I know that my right triangle rule worked. That means this is a right triangle. Select whether the given sides do or do not form. So here we go. A, B, C. 9 squared plus 15 squared equals 19 squared. 81 plus 15 times 15. 15 squared is 225. 19 squared, 361. When I add these two values together, I am going to get 306. Like I said, these are not the same, so this is not a right triangle. My formula did not work out, so this is not a right triangle. All right, use the Pythagorean theorem to determine the distance between 2 points. Well, if I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, I need to have a right triangle. To form my right triangle, I need a vertical distance and a horizontal distance to form a right angle. So from one of my dots, I'm going to draw a line straight down or straight up. And I'm going to draw a horizontal line, connecting that in, and I can see that I have a right angle right here. Now my shortest side is A, My second longest side is B, and my longest side is C. Your C is always going to be the slant across from the right angle. So here we go. A, well, how long is A? That's 2 units. So 2 squared plus B is 1, 2, 3, 4, 5, 6, 7, 8 units equals C squared. I don't know how long the units are because it's a slant. So 4 squared plus, right, not 4 squared, 4, 2 times 2 is 4, 8 squared is 64 equals C squared. Add these together, I get 68 equals C squared, and I'm going to use my calculator to take the square root. Square root of 68 is a grand total of 8.246. 8.246. It asked me to round to the nearest tenth. So I'm going to draw a line after my 8.2. Does that 4? Is that enough to round it up? And nope, it is not. So 8.2 is my final answer. Using the distance formula to find the distance between points. Remember the distance formula, and if you don't, write this down. x2 minus x1 squared plus y2 minus y1 squared. And I ran out of room. Here we go. I label my points. X, Y, 1. X, Y, and these are my second point. And now I use my formula and plug in. So square root, parentheses, x2, 10, minus x1, 2, squared, plus, parentheses, y2 is negative 7, minus, so I write down a minus, 4 squared. Okay, and now I'm gonna simplify this. 10 minus 2 is 8 squared. Negative 7 minus 4 is negative 11 squared. Now put parentheses around that negative 11 so you don't end up with any negatives inside my square root. 8 squared is 64. 11 squared is 121. I'm going to add those together and take the square root. So the square root of 64 plus 121 is, and my answer's over here, 13.601. Round to the nearest tenth. I draw my line after 1 decimal place. That 0 is not enough to make my answer round up, so my answer is 13.6. Volume. Make sure your calculator is still handy for this one. So the radius of a cylinder. The second I see the word cylinder and see a picture of the cylinder, I need to know what equation I am using. That is pi r squared times height. So pi times r squared times height. You'll notice in the problem it says to find the volume, use 3.1 for pi. So I'm going to rewrite my formula. 3.14 times r squared times height. And we're going to round our answer to the nearest whole number. So 3.14 times my radius. Well, what is my radius? Well, I can see from the picture, half the circle is 2 feet, or I can read it in the sentence that it's 2 feet. 2 squared times my height. Now, if you're thinking the height is the circle, then you're going to run into troubles because the height is always the distance between the two circles. The distance between these two circles is 17, so I'm going to multiply by 17. So in my calculator, I'm going to type this all in. So here we go. 3.14, clear it. 3.14 times 2 squared times 17, and it's going to give me my answer, 23.52. is what exactly I get. Sorry, 113.52, my bad. Nearest whole number, so no decimals, but make sure you look after the decimal. Does that 5 make that round up to 214? Yes, it does. It is bigger than, it is halfway there. So 214 is my answer. 2 feet cubed, but it has my units already written there. Diameter of a cylinder. Diameter is all the way across. Remember, my formula is only halfway across. So the radius equals 4. That's half. I'm going to follow my formula. 3.14 times, because you'll notice it says use 3.14 again, times radius squared times height. Here we go. 3.14 times my radius is 4 times my height. 7 from circle to circle. So that's my height. Type that into my calculator. 3.14 times 4 squared times my height. 351.68. No decimals. Does that 6 make that round up? Yes, it does. So 352. Cones. The radius of my cone is 3 inches and the height is 10. Now my formula for a cone is a little different, but it's really actually quite similar. It is pi times r squared times height. Now so far, so similar to the cylinder. All divided by 3. So here we go. Find the volume. Use 3.14 for pi. 3.14 times my radius of my cone halfway across the circle is 3 squared times my height, which is 10, divided by 3. So I go to my calculator. Now be careful on this one. Click the fraction button on the right hand side first. 3.14 times 3 squared times my height. Oh no, I forgot what that was. 10. All divided by 3. Click enter. And I get 94.2. No decimals in my answer. So does that 2 make that 94 round up? No, it does not. 94. Last one, a sphere. My formula is a little different. It is 4 times pi times r cubed. Notice that's a difference from the last one to this one. The third power instead of squared. 4 pi r cubed divided by 3. Notice there's no height in this equation, just my radius. You can kind of think about it, just my radius. So how do I answer my question? Find the volume. Use 3.1 for 4.4 for pi. So 4 times 3.14 times my radius. My radius is 9 centimeters. So 9 to the third power divided by 3. I'm going to type this in exactly into my calculator. So here we go. 4. Clear it. 4. Oh, and one other thing. Make sure you type the fraction button first. That a over b. 4 times 3.14 times my radius, which was 9, to the third power. Now, if I want to do any exponent, I have to click the AB button, the one next to the a squared, to the third power. Click back into the bottom, divided by 3. So what is my answer? If I round to the nearest, so 3052.08. Nearest whole number, that 0 is not enough to round up, so 3052 is my final answer.